start recording. I just have a couple slides to go over today before I'll release the quiz on Canvas, just reviewing some of the stuff we talked about last week, and also some of the computer control that's in Lab 6 as well that would traditionally have been done with command line and controlling like your KDMM, like how you guys are using KDMM reader. Let's see. Okay. So last week, just as a brief review of some of the stuff we talked about, and what we traditionally would have done would have been controlling the temperature of some sample holder, but also I'd use the example of things like controlling the temperature of the oven or controlling the temperature of like thermostat in your house and different types of system control for that example. And we went over the most simple one of just doing on off, where this blue line here at the bottom. Are you guys just seeing the slides? And can you see my mouse?
Yes. We can also see like the next slide as well, but it's kind of better this way since the...
Okay. So yeah, I guess that's because I have my two monitors, but so this blue line here is the power just turning on and off. And then you see you have this oscillation of the actual temperature in green versus the set point temperature in red. So that's the simplest control we went over. And then we said, oh, if we control how much power we're applying, not just having on off, but 10%, 20%, 80%, depending how far away you are from that set point, you can then have faster rise time here to reach to that temperature, and you can get somewhat closer to the set point temperature. But you'll always have a certain offset, and these three different curves here in blue, green, and cyan have to do with like how much gain or how much proportion that you're applying. And then the last part we talked about was the PID, or proportional integral differential control, and that helps get rid of the offset and helps control how fast you're making that change and any error that you have. So that's just a brief review of those different plots that we showed, where again, this dark blue line here is the power. And my brother's actually an electrical engineer, and last year I asked him, oh, what have you used PID control for? Because we're just using it for temperature. And he's like, I've only used it for temperature. But he works for Siemens and works in Detroit with like the auto industry, but he was going out to California for about a year and a half and helping set up the Tesla factory for their Tesla 3 cars, which I got to hear a lot of interesting stories about how poorly that factory was run. And I don't know if any of you guys are big like Elon Musk fans, but we can talk about that another time. But he said that they used their PID control so they could have, since they were way behind schedule of making the Tesla 3s, they made it so like the ramp up time would be like really fast, so they would reach the temperature, but they would overshoot and oscillate. And he's like, I bet in 2 or 3 years, all of the paint on the Tesla 3s are going to be like falling off, and because they didn't like use a lot of control. So that was just, I thought, an interesting story of like how PID control is used in industry, and it's really like applied for temperature, even just like the simple control that we would have been doing in lab.
We use PID in the Morse Center a lot as well.
Mm-hmm. For
the angstrom deposition machine.
Okay.
It controls a power output of an electron beam that's used to melt and evaporate metals. But it's really sensitive, and we use PID to make sure we get even coats because they're nanometer level precision.
Mm-hmm.
So.
And do you have to put in anything for like the?
I mean, yeah, it's really, we struggled with it for a while. There's a whole buttload of stuff we have to mess with it, but we just got pretty good at it. But it fights off a lot of the problems that you were just talking about. The biggest one that we dealt with was recurring oscillations, so that it like stuff would overshoot and then it would come back down and undershoot, and then you got stuck in this oscillation pattern. But then we changed a bunch of the integration controls so that it slowed down, and a lot of the differential controls so that it would stop doing that. But yeah, it's really nice.
Yeah. So, I mean, that's what you'll be walking through tomorrow. So I guess, Robbie, you have some experience with doing the playing around with the different amounts of gain. And tomorrow you'll be walking through.
Hey, Robbie, would you like to be partners?
I'm with Errol.
Three-person group.
Yeah, but I mean, don't worry. This lab is, it really hold your hands are part of it, of playing around with just the proportion, the integration, and the differentiation here. So last week we talked about these different gains. You'll be going over what the output is versus the error that you have and your set point. But you'll be doing that trial and error process, but also the lab briefly mentions that there's other methods that have been applied that isn't just trial and error. They're more like heuristic phenomenological methods where they're saying like, okay, you get pretty good performance if like you set the proportion to a certain level and then you have a certain fraction for the integration and a certain percentage for the differentiation, and some ratios that some people have optimized. But again, it's a very empirical type of control of a system. So that's just a brief review of PID. That will be the first portion of Lab 6. And then the second portion of Lab 6 has to do with, I guess I had all these that we talked about last week. And the lab will walk you through that. But the second part of the lab is going in a little more detail of the national instruments and the GPIB control, that if any of you guys had issues during lab during the semester of not recognizing the KDMM, you may recognize the screen cap right here of looking at the different addresses and how your computer communicates with your instrumentation and what addresses they are at, how you can ping those, how you can assign those addresses. So going a little bit over the details of recognizing the addresses and what different instrumentation companies assign as the default addresses versus sometimes your computer has its own mind and will assign some random address. That was some of the troubleshooting that we've had to work on in lab before. But also there's ways that you can actually see this communication back and forth in National Instruments. So there's something called like the NI SPY. So going over some of the documentation for this. And in the future, if you're in junior and senior lab and you're not getting the right communication or the right output, this is a nice way to just open up and see, like, is the communication happening or is nothing going on? So going over what some of the commands are between the instrument and your computer, it'll walk you through that. So that's one environment of the GPIB, is working with National Instruments, but also you can interface with your different instrumentation with different programming commands that every single instrument has that's connected through the GPIB. So these are some examples from the KDMM of, you should recognize like the different measurements that it can do. You can see like getting DC volts or AC volts or the resistance out. You can type out like F0X will give you the DC volts. So F0 is saying the function of DC volts, and then X you type in to say like execute and actually do that. We can also see like the same way that you guys can hit buttons on the front panel of the KDMM to change the range, you can actually program that in through the National Instruments interface. So this might be useful. Let's say you're setting up a measurement that you want to monitor over like the weekend or overnight, that you can write some type of function where you can say, okay, I want to monitor the AC volts in this certain range for like 5 minutes. Then you have something change in whatever you're measuring and you want to, it's increasing the scale. You can program these things so it's automated instead of having to like sit there, which is especially important for long experiments. So there will be a little bit of going over what these different commands that you can put in for the KDMM, also for the ARB, just so you're familiar that not all the commands work for the same type of instruments. But it's, unfortunately, you won't be able to actually see this on the instruments, but looking in the manual is just to give you guys a taste and an idea of how different HP, how Keithley, how the DSO company, that the different types of functions that they use. So that's all I had just with this brief PowerPoint. Do you guys have any questions? Okay.
Yes, but none you can answer.
What type of questions are just too big for Phys 204?
What are the answers for the quiz?
Oh, okay. Yeah, sorry.